Secret.
Yeah. Well. Good evening, everyone. My name is Raj, and I'm the co-founder and CEO of Connexio. And I have Ryan with me, who's a good friend, and he is here to talk about data science and data engineering. Just to give you a little background about Ryan, he has an undergraduate and a graduate degree from SIUE in economics and finance, about 6 years of work experience in data science, and he is currently working at Slalom, which is a consulting firm. Ryan, welcome to the show.
Thanks, Raj.
Thanks so much for taking out the time.
Of course, happy to be here.
So we're going to start with answering questions. The way we're going to do this is we're going to segment the first 30 to 40 minutes with the data science and data engineering questions. And those questions are the ones that you guys have asked when you filled out the registration forms. And then we're going to go into the immigration questions and questions about admissions as an international student, and I can go ahead and answer those for you, right? So without further ado, let's jump into this. So Ryan, the first question comes from Abhinav, Smahi, and Jaskiran, and they ask about data science. So explain what data science is all about, right? What's the scope? What is?
Of course. Yeah, which is always an interesting question. I'd like to preface that just by saying that a lot of these questions that were asked were sort of intermingled between data science and data engineering. And I just want to clarify that a lot of these answers are going to be covering what would technically be both. I don't see a whole lot of distinction. Some of the industry does, and we'll talk about some of what I mean by that here in a little bit. But just know that those two things aren't mutually exclusive. They're not explicitly separate things. But the specific question here is, what is data science? What is this big buzzwordy term that gets thrown around a lot? So what I've learned in my experience is that data science isn't one thing, because there isn't really a clear definition and agreement on what it is. In fact, if you go on the internet and were to look up what is data science, you will get a ton of people yelling at each other trying to understand, excuse me, and define what data science might be. So as opposed to going down that route, what I have noticed is that what is universally true, though, is that data science covers and works within a ton of different fields, whether it's biology, chemistry, neuroscience, economics, finance, business, technology, software development. It really is more of a tool set, from what I can see, than it is a specific field. Some people will disagree with that, but that's a lot of what I've noticed.
So Ryan, if I were to cut you right here. Sure. So essentially the way I understand data science is that in this day and age, we are generating data at every single point in every single type of business that we do. Yep. It doesn't matter if it is in biology. It doesn't matter if it is, e-commerce business or whatever it is. But there is, the world's understood the value of data, right? And as they're going through it, right, the field of data science is picking up, where people in this particular field go and start making sense of what is getting generated.
Yeah.
Right?
Correct. And that leads me to sort of my next point, which was that, excuse me, if you look at not so much defining what data science is and isn't, what I like to think about is what can data science be. Right. So what you'll see a lot about the work that data science covers, excuse me, is it's enabling people to make predictions with data, make forecasts off of data, telling a story with data that exists from your customers or your clients or your patients or whatever. It could be moving data from one place to another, which is sort of what people refer to as data engineering in a lot of cases. Different transformations, aggregations, visualizing data, putting it into pretty graphs, charts, websites, whatever it may be. It's really embracing the abundance of data, relational data that we have these days, and being able to work better with it. That's about as abstract or as specific as I'd like to be about that. I don't want to show up on the internet as somebody else with a different opinion of what data science is. So those are the different things that data science can be described as, and some of the work that you might do if you were to work in a field that describes itself as being data science work.
Right. Okay, cool.
Hopefully that answers the question.
I think it does, pretty much. So guys, I want to mention this right here, that Ryan's been kind enough to actually put all the answers in written format. So we have everything right here. If you see him peeking down, that's because he just doesn't want to miss any points. Yeah. Also, we're going to put the whole transcript of this video on our blog. So you get another email from us in a week or so with all the links. So you don't worry about taking notes. We're going to put all the URLs and all the things that Ryan refers to in the URL there.
Yep.
All right, moving on. So Tanmay asks, how are machine learning and data science related?
Sure. So that's an interesting question. It's sort of easy to answer, but I think that it's important to frame out when somebody says machine learning, what it is that they're talking about. So machine learning is a subset of broader computer science. And within that is artificial intelligence, which is something that I won't go into too much. But machine learning is the ability to apply statistical methodologies to teach a program how to do something without specifically telling it what to do. So if I wanted to, I could write a game of chess. I could write a program that plays chess against a person. And I could say a ton of times over and over again, if the player moves their pawn here, and this is my piece, I can move it here. Or if they move this piece, and I could write a ton of just ifs, and it would be this huge program that would just be checking and seeing every possible outcome of what could happen in the chess game. Or I could use statistical methodologies to collect data and observe thousands, hundreds of thousands, millions of chess games, and I could have the computer itself figure out how to play chess based on what it has seen, as opposed to having everything explicitly told what to do with it. That's a common example that people use. And in fact, machine learning was first used to describe a chess robot. Like that was in the 1950s. I forget the man's name, unfortunately, but that's where the term came from. Today we use it for a lot of things, predictions, forecasting. Machine learning is a lot of applied statistics, which is something that I'm very passionate about. So the question again is, how are machine learning and data science related? If your job is defined or is described as a data science job, you're probably doing machine learning. That's what a lot of people consider to fit into that space for. Excuse me, because with the volume of data, like Raj talked about, that the world is seeing now, everything has data everywhere in one way or another. Machine learning is a way to is a set of tools that allow you to explore much more quickly and robustly the data that's available to you. You can describe it, make predictions about it, or make recommendations based off of it. So it's a very powerful field of study, and it fits into the bigger data science picture.
Got it.
Good question.
So the next question is from Suraj. He asks if data mining is a part of data science.
Yes. Yeah, the answer is yes. And data mining is a weird niche term that I don't use very often. But data mining employs machine learning. This is my experience with it. Employs machine learning, so applied statistical methodologies to discover patterns in data. That's the broad definition of data mining, is discovering patterns in large amounts of data. And just like everything else, if it says data in the name, it's probably data science. So
got it. All right. The next question is from Keshav and Rishabh. And what they ask is, can working as a data engineer further our chances to work in the field of AI?
Yep. I would say yes. And in fact, I would say that it's almost necessary. So when somebody says data engineering, we talked about this a bit a few minutes ago. What they're really talking about is the act of working with data. So you can imagine, and this is not an opinion I want you to take seriously, but just for this example, data science is the factory that everybody works in. Like, it's the factory itself. Data engineering are the folks that are working in the factory, that are moving things around, stacking boxes, organizing things, labeling, shipping. They're handling all the logistics within that factory of data science, right? So data engineering is a fascinating field of work. It's a lot about, and we'll talk a little more in a little bit, things like ETL is a term used to describe, extract, transform, and load data moving around. If you don't know how to work with and process data, you're not going to have any success doing any work in artificial intelligence. You can't just expect, and you'll see this if you gain experience working with more and larger data, you can't expect that the data you get is going to be in a really good format so that you can start giving it to something to become an artificial intelligence program. You need to spend a lot of time cleaning it up, preparing it, doing things like that. So to answer the question again, I would argue that it's necessary to have data engineering skills to succeed in artificial intelligence work.
Got it. So I want to inject my own question right here. So could you tell us a little about how you would relate, data science or engineering with artificial intelligence and machine learning? Since we've talked about those two terms separately, right? How do those converge in the field?
Sure. So I think I answered that a few minutes ago, but data science, again, is what I see as, and again, this is what I'm describing it, the can be's, not the is the larger field of skill sets and tools, which encapsulates things like machine learning, artificial intelligence, which some people would disagree on that, because artificial intelligence is a very specific computer science field. It's well defined and it's existed forever. But given that we have this large volume of data to facilitate things like better predictions, better artificial intelligence design and things, to say that it doesn't fall under the umbrella of data science is probably a mistake. So again, to address your question, Raj, is that if it data science is the term that encapsulates all of these things.
Right.
Is how most of the world would view that.
Right. But dude, so if I were to assume, right, and this is me just talking as a layman right here, if I were to assume that machine learning is sort of a subset of artificial intelligence,
it is.
Right?
It is a firmly defined subset of artificial intelligence. I've been burned
right.
by exploring that answer.
Right, because what we are essentially doing is we're telling this program to go through tons and tons of data, right? Make sense of it, right? And then become aware of what are the other possibilities that could come out of a particular action, right? And as it becomes more intelligent, right, we basically move into the field of artificial intelligence with the same program moving one step ahead in the evolution. Is that something that I'm understanding correctly?
That's a good question. I think I see where you're going now. It's, for me, I'm nowhere near as familiar with what academia would call artificial intelligence, because that's a very reserved term for higher academic computer science people. And I'm able to describe machine learning because it's really just applied statistics, and I've done most of that in my career.
Right.
Artificial intelligence is the same, but I can't speak to how specifically different it is from machine learning itself to roll up to AI.
Got it.
I know that somebody can answer that better, probably with a really strong opinion.
Right.
So I don't want to step on anybody's toes.
Got it. Makes sense.
Yeah.
All right. The next question comes from Shivam. What he's asking is, what are the things that data engineers work on?
Yeah, which is a good, fair question, because why care about the field if you don't know what the work is going to be? And I should preface that by saying that's true of all fields. If you think you want to be like a medical doctor, make sure you know what the work is like. Make sure you know what you're getting into, things like that. So what a data engineer, and again, that fits within the realm of data science, what they kind of work they do is they can do machine learning work strictly. So they can take data that's coming in, fit what are called, if you haven't done a statistical thing, they're called models, work with models where you define different characteristics of how the data works, like with variables and things. And then you spit out predictions or inference or something like that. That'd be more like a purist kind of work. Then you can do predictive modeling or forecasting. A lot of my work, especially in academia, has been in time series analysis. So being able to take in data that occurs at some frequency, like monthly sales data, and then I can predict the next couple of months of sales data. You can do work like that. A lot of my work has also been in, and I'm speaking for myself, but this is broadly also true, has been in what's called ETL. ETL stands for extract, transform, and load. What that means is get data, do things with data, send the data somewhere else, which is incredibly valuable because data doesn't just sit in one place. You have to know how to move it around from one place to another. Some people build entire careers out of ETL development. Some people never touch it. The most successful people will know a little bit, at least. I happen to know a lot. A lot of my last job was all of that. So you can process data, you can clean data, you can design novel ways to prepare data. You can be a database administrator. Again, data science covers a lot of things. Being a database administrator, like a systems engineer for maintaining good relational data sets, like with SQL and things like that, falls within that realm as well. One thing that I noticed, though, I have an etc. I keep looking at the sheet because I'm trying to make sure I tell you what it is that I've written down. You will write a lot of code. in a lot of languages. Like a successful data engineer and data scientist needs to get that down. And we'll actually have, there's a question about that here in a little bit that we'll address. There's an adage that I missed earlier that goes around on the internet a lot, which is, it says 90% of data science is data preparation. And then somebody who I admire very much tacked on to that. He said, well, 90% of data preparation is software development. And so by math, 81% of a data scientist's job is software development. So you will write a lot of code. It doesn't have to be the most perfect, beautiful code, but if you're afraid to touch programming languages, then data science probably isn't for you. And a lot of the tools they use are pretty easy to work with compared to some other really terrible programming languages. But just forewarning, that's the kind of work you do. I love it. I'm super passionate about software development in addition to all these things. And so it's just all the things I like to do are all bundled up together.
Right. All right. Moving to the next question, which is from Shivam again. He asks, what's the average package offered to a data engineer in the United States, let's say, because that's the area that we are in.
So, and to clarify, does package mean?
It means
compensation.
Compensation.
Sure.
Yeah, salary offered.
Okay.
So we could probably give them a low and a high. It's hard because it depends on
location,
geographical location where you are. But correct. Let's say if a data engineer were to graduate out of an undergraduate, right, with no experience.
Okay.
Right.
Undergraduate degree. Let's start there. Undergraduate degree, no experience, no work experience, specifically in a field of data engineering. In St. Louis, Missouri, where we are, you could probably get started for $60,000 US per year, along with things like health insurance and whatever I can't speak to. Things like that. That's really, really low. If you have some experience, it's pretty easy to get compensated more quickly, faster, because it's a skill set that's incredibly high demand.
Right.
It will only continue to be in high demand. It's much like computer science. It's probably never going to go away. The name might change, but the work won't go away.
Right.
I mean, comfortably compensated. Like let's do St. Louis because we have a pretty low cost of living here. I mean, probably you could expect to cap out, like hit your limit of income before you start doing managerial work, probably like $150,000 US.
Yeah.
I can't speak for that. I don't make that much.
Yeah, and it's also it depends, as we said, it depends on where you are located.
Yeah.
Right. It's got nothing to do with whatever we are saying. These are just numbers.
Yes.
Right. We don't want to make claims that
I'm speaking from my experience, what I've seen, and what I know that myself and my peers have heard in the past. I will say as well that because it's a high demand field, like software development, like what was the other one that I just said? Excuse me, computer science broadly, like things like that. Data science, data engineering, you should be comfortably compensated. Like you would think that coming out of an undergraduate degree with no experience, you should be able to live alone. Okay.
Yeah.
Yeah. Like it's not low pay. It's not,
Right. And I don't want to talk more about it. It just gets into too much regulatory stuff and all that stuff. And we're not the right people, right? It's just a question that we wanted to answer it.
Yeah, I went to undergrad and graduate school for economics. My focus was on labor economics. And so talking about things like wages and income and stuff like that is something that I've done a lot of research on. It's a high skill field. It's a highly educated field, and it requires smart people.
Right.
So they're compensated accordingly.
Right. So the next question is from Rajneesh. What kind of jobs can a data engineer get? And I think we've talked about that, right? But just to spend another 30 seconds on it, right? Go for it.
So jobs, and when people say jobs, I think they're usually thinking of titles. Like what is the title that I will have at my place of employment? Don't worry so much about titles for any career path. So I have a note here, and I'll answer these questions in a second. In the U.S., at least, your career and your title and your everything is not dictated by the degree that you get or your course history. I went to school again for economics and for finance. I am neither an economist nor a financier. I am my career has changed quite a bit. I'm now what's called a DevOps engineer, so I actually do a lot of more software development. None of that touched any of my academic studies. So I would just say that as far as how that's considered. If you have data engineering skills, which my degrees did prepare me for, what kind of jobs can you get? Again, I'll read through the list I had here again, and I'll think of some others. So machine learning work, you can do database administration, ETL, you can get into software development, more so, a lot of it's data touching. You can do a lot of cloud development work. And I have some things about important skills to have. Cloud hosting providers like AWS, Google Cloud, Microsoft Azure. These are things that will help you, like knowing how to work with the tools they have, will make you not only a more valuable employee, but there's some jobs that are strictly focused on cloud development work, which is a lot of what I do these days. Yeah, anything that can touch data, tabular data, especially tabular as in rows and columns. If the job description says it does that, then you can do that job.
And it could be in any field, because every single field is now picking up data at this point.
No, that's going back to what we said earlier,
right.
Is that it's data science is not something that I put air quotes around. I love that word a lot. I don't like the term very much. It's not a field per se. It's much more of it's the broad tool set foundation that all modern fields sit on, because we have so much data. Data science is the set of skills and knowledge that allows us to interact with that. That can be biological sciences, chemistry, mechanical engineering, business, fish farming, whatever. Right. It's a lot of things you can do.
Right. Okay. And guys, just to let you know, my colleagues are monitoring the chat. So if you have questions, just ask those questions. If you don't get to those questions during this session, Ryan and I will make sure that we answer all those questions in the transcript as we post that on our website. So feel free to ask all your questions on there if you think something we've missed out and you wanted to hear about that, right? Next question comes from Naman, and I think this is one of my favorite questions. Data science looks boring, he says, as compared to fields like web development, computer vision, game development. Is it different from what I perceive it to be?
I also love this question.
Yeah,
I love this question because when I was thinking about answering it, I had to think about how do I defend the tool set that data science, data engineering falls under. And I didn't have to try very hard after I started thinking about it, because the three examples that Naman gave here are computer vision, game development, and web development. Anybody of my peers that I were to ask, would you consider computer vision to be data science? They would all say yes, universally. Like that's an applied case of machine learning, which falls under data science purely. Depending on what kind of web development you're doing, oh good, you had the last part too. What kind of web development you're doing, that's probably also data science. The majority of my personal work, I do a lot of cloud development stuff now, like I'm more of a software developer than a data scientist these days, but all the software that I build is to facilitate data science activities. And I do a lot of my work in web frameworks. I write a lot of code. If you're familiar at all with Python, we'll talk about this in a bit. There's a framework called Flask, which lets you write endpoints for servers that you can throw HTTP code at. I write a lot of Flask applications that listen for requests and spit out data, relational data, like that has forecasts on it or something like that. So if you're going to be a successful data scientist or data engineer, web development is important. Not necessarily front-end JavaScript stuff, but you need to understand web development for sure. And then for game development, again, I didn't want to touch AI, artificial intelligence, as a field, but in video game development, we talk about how, like, if you're fighting like bad dudes, like bad enemies in games, how they have AI, like, because they'll come after you and they'll fight you with artificial intelligence. There's a lot of these cases that aren't really AI. It's more like they're programmed to, if my player is standing here, throw a bomb, right? So it's much more like fake AI and things like that. But modern games employ actual statistical artificial intelligence all the time, which again is, while its own field, is supported by the skills and the tools that data science allows to work with.
Right.
So Nama, to answer your question, all of these things are data science, and you got tricked.
Right. So yeah, it is as cool as anything else that you've been listening about.
Yep, that's correct.
Right. So the next question is from Naman again, and he asks, how strong do you have to be mathematically to get into the data science field?
Well, it's worded a little differently. To get in, not that much. You need to understand mathematics. You need to understand some fundamental things so that you don't, so that you understand what is going on.
Yeah.
But a lot of the experience you'll gain, I mean, you'll never stop learning about math. There's too much, and you can't learn it all in school. You'll have to pick up some on your job, as I have in my career. To succeed as a data scientist or data engineer, you want to have a strong mathematical background. It's really, really easy to get into it. Like I said, you can read an online tutorial about how to do these things and what some of these things mean and how to interpret the outputs of a linear regression, which is a common thing you'll see. But to actually work and think independently in the sphere of data science, you need to be able to do more than just read, copy, paste. I think I've seen some of this math before. You have to be able to independently know when to apply what tool set and how.
To make sense of the data.
Correct.
Right.
And that's relevant everywhere, whether it's strictly data science things or if you're doing software development, if you're doing computer science, like mathematics is incredibly important in all of those things. A lot of people will disagree with me on those. I've read a lot of things on the internet where casual people will post and say things like, no, you don't really need to understand math and stats. Most of it, you just push a few buttons and then you can make $1 million, but that's really naive. And to be successful and to be comfortable in your work, you should have a good understanding of mathematics and statistics.
Right. And just bringing this down to, I just remember the one time that you and I were working together, making sense of data from one of our clients. It was so important for us to understand how the sales have been happening in the last few years, right? To predict how things are going to go, in the next 4 or 5 years, right? So if you are not statistically that good, you'll be able to get to putting that data together, but you won't be able to do the next steps, which are, forecasting or other stuff. Yeah. And then I think it also depends on if you want to go into that area.
No, right? that's a fair point too. It's the data science work is more prohibitive
right.
the further you get into it. So you can get into things like, you could write, you could be a database analyst. You could be like a data analyst, which
right.
is another just word to describe kind of work you do at a low level with a low set of technical skills. And you can stay there and you can be comfortable with that for the rest of your life. That's fine. It doesn't
right.
matter. But the further you go towards things like, if you're pushing from nothing towards things like AI, let's say, right? I'm being general here, but the further you get towards the more statistical fields, the stronger your math and stats background has to be.
Right.
But you can get in and you can work your way towards a point you're comfortable at. And if you don't want to learn how to take the third derivative of a non-differentiable model, then don't.
Right.
You don't
right.
have to do
it totally
that.
Depends on you. So, as Brian said, it just, as you climb up
mm-hmm.
and whatever you want to do, that should essentially define how much math you need to learn.
I would like to say really quickly that the most important, because we could talk about like what's important for
right.
the field. Well, the most important thing is, yes, math and stats and things like that, but the most important thing in thinking about data related work is subject matter expertise. So they call that SMEs, like subject matter experts sometimes. But what that means is understanding the industry you work in. It doesn't matter if it's business, it doesn't matter if it's sales, biology, whatever, any natural sciences. The majority of the success that I've had with projects I've worked on in the past is not so much because I know how to automate prediction models. It's because I know what that data looks like.
Right.
I know what the business goals are. I know what they're trying to achieve. I just happen to have the tools to help them do that faster.
Absolutely.
Right.
Yeah.
So yes, all the data tooling and stuff that we'll talk about here is super cool and I love it. It's infinitely more valuable just to actually do what we've done for hundreds and hundreds of years, if not longer, just understand your work first. You can't go in and try to throw these tools at work you don't understand. You have to understand your job first.
Right.
So
cool. The next question is from Nisha, and she asks, would you suggest learning pure statistics? And I know it's just an extension of what we've just talked, but let's spend another 30 seconds.
Yeah, I did write a longer answer for this because I said, yes, absolutely. I'm very passionate about statistics. I often guest lecture at the university I graduated from in business statistics. It's a wonderful field of tooling study. So basically statistics, it's roughly defined, if you haven't taken any stats courses, it's roughly defined as being able to understand the whole picture from the part of the picture, broadly speaking. And so what that means is I can take a sample of something and understand, because of this sample's characteristics, understand the population. I can look at historical data and then make predictions about future data. All of this stuff is all part of the same principle, which is you have something that you can observe. What can I say about the stuff that I can't observe?
Right.
And that's not just for data science and stuff. That's for any field. Statistics is incredibly fundamental and valuable, and everyone should at least take a few courses on it for critical thinking stuff.
Right.
I'm passionate about that.
Cool. Next question is from Nisha again. PhD or master's for data science or computer science people.
So if you haven't thought really hard about your career goals, like what it is that you want to do, master's is not a bad place to start, right? Because it's a graduate degree. You can even, there's a lot of programs. We worked with somebody who was working on a PhD, decided to leave early, but because of the way their program is structured, they got a master's degree anyway.
Right.
On the way out, they got a master's degree. Right. So PhDs take a lot of time, a lot of effort. I almost went for one and decided at the last minute that I personally didn't want to do it because it would have been 7 years of work, 7 years of additional work on top of my graduate degrees. And I wasn't even sure if it's really what I wanted to do. Some people are all about that. If you want to pursue a PhD out of undergrad, think about it. But think about a master's first. Masters usually only take a year or two.
Yeah.
During that year or two, you can actually have hands-on academic experience to see if a PhD is what you want to do. That's a good question, and think about that. One thing I will say, though, can I say this? Are you gonna let me say this?
Go for it. Go for it.
You see that I keep putting data science in air quotes like that. Data science is being treated by both industry and by universities in the United States, at least, as kind of this big. We call them buzzwords in English. They pop up. These degree programs pop up, and the people who are teaching them don't really know what value it provides outside of the course content itself. Is very valuable. You'll couple things like statistics and machine learning and critical thinking, but I wouldn't be surprised if in 5 or 10 years in the United States, if data science as a degree doesn't exist anymore because it came up because students in industry thought they needed it.
Right.
So what I'm saying is that PhD versus master's is a great question. I wouldn't be too worried about focusing on whether or not it's a data science degree. Figure out what you're passionate about. Figure out what are the things that you want to learn and get careers in. And be able to allow you to go around the world if you want to and work in different places. And then think about that. Think about the degree type that supports that, whether it's computer science, statistics, mathematics, biology, whatever, and then go down that path. I don't know anybody who I've ever worked with or know that has a master's or a PhD in data science. They come from backgrounds, and plenty of them have PhDs.
Right.
They come from backgrounds like mathematics, biology, biochemical engineering, neuroscience. Like, these people all ended up being data scientists without a data science degree.
Right.
So go ahead.
Yeah, if I were to just reframe what Ryan said, Nisha, this is for you. There's what Ryan's trying to say is don't narrow yourself into a particular program just because it says data science.
Correct.
Right. And this question next, which is from Sushma, we'll talk more about that. Right. But once you decide that you want to go into a PhD, that PhD has to be in a particular area of data science, because data science is huge, right? And we've talked about that a bunch of times. So once you go into your PhD, then you basically decide what very specific area in the data science, ecosystem you want to work on. It could be AI, it could be blockchain, you could be doing, something in biology, right? Figuring out DNA structures and all that stuff. So all that is data science as well. So don't limit yourself if that answers your question. So in the same breath, I want to talk about Sushma's question, which is a really good question, right? And for everyone who is aspiring to be a data scientist. Does a master's degree in data science limit your opportunities as compared to a master's in computer science?
Yeah, and I would say to that, in addition to the last question, yes, it limits you. That's my opinion. I'll say that this is my opinion because this is like it's a future thing and I can't predict perfectly the future. I would say yes, it does limit you because computer science as a field is time tested. We know what that means. Like the world knows that if you have a degree in computer science, you have a pretty good understanding of computer science. If you have a degree in data science, no one really agrees with what that means. And you could get a degree in that, and then 2 years later, the entire curriculum from your university could have changed, and now you have people coming out with degrees in something entirely different, but the same name. But again, you can do plenty of data science work with a degree in anything, especially computer science. Like I said, 81% of, this is an adage, 81% of your data science work is software development, and you have to have a good understanding of computer science, software, operating systems, things like that. So think about that. You know, if data science just sounds cool, you know, you can do that work no matter what your degree is. If you were thinking about computer science anyway, explore that as a passion. And if it's really what you want to do, go for it. Right.
And it's all about essentially picking up the coursework during your degree. You know, it doesn't, so somebody who's picked up masters in computer science, right, and picks up coursework, which is heavily concentrated on data science, right, that just shows your interest and that's where you want to go, right? But your degree is in computer science. Right?
All of your core competency will still be in your degree name, but you'll be able to, I mean, depending on the university and the career or the track, you can pick up as many electives of whatever you want as you want.
Absolutely.
Excuse me.
Right. But if you just do, you know, a master's in data science, then that just basically limits you to that particular area. And doesn't matter, as Ryan said, right? Once you get into the industry basically, or your job, your field of work defines what sort of an evolution you go through, right? So our suggestion would be to pick up a general degree and then figure out, you know, what sort of cluster of courses you want to take to build a good repertoire.
And there's always during your degree, there's always internships,
right,
which aren't specifically limited to your degree either. Right? You could be doing a PhD in biology and get an internship in a bank.
Right.
You know, you have plenty of options to explore your own interests and passions.
Totally.
I'm speaking for the U.S. here, but that's how it works here.
All right. The next question is from Pankaj. Is it necessary to have experience in data science for pursuing a master's degree in the field?
This is pretty quick. The quick answer: no, because of all the reasons we've talked about. It's not really a field in the way that a traditional sort of discipline is. That's a good question though, because there's a lot of fields that should you choose to go down them, you can't get a PhD or a master's if you don't have a bachelor's in the same field.
Right.
So I know that for a master's degree, this is weird to me, so I went to school for econ. A master's degree in economics, you don't need a bachelor's in economics, but for a PhD in economics, which you can come out of undergrad for, you need a bachelor's in econ to get a PhD in econ, which is weird.
Right. And I like to point out here, right, that when you do a master's degree, the reason why you're doing a master's degree is either you want to go into a specialization of a field that you've done in your bachelor's, or you want to just pivot, right? Like I pivoted from mechanical engineering into engineering management, right? And Ryan actually just went into econ still for his master's. So you could be a computer science major in your bachelor's degree and decide that you want to go into the field and, you know, hone in on your skills on data science and then move towards that. Or you could be an electrical engineer and still decide you want to go into biochemistry, for example. You'd have to take some basic courses, but that is the whole crux of doing a master's degree, that you can choose a different field and move into that direction as you work, right? Okay. The next question comes from Sushma and Tanmay. Important math courses that a bachelor student should take for a master's in data science, or just to prepare himself or herself better.
To prepare for data science work.
Right.
And this is a pretty quick answer. I have to bullet it out. So for mathematics, you'll want to take enough calculus. Is it called calculus? Enough calculus to cover limits, derivatives, the rules like the product rule, integrals, and probably Taylor series, I think. And if you've taken calc, this would sound familiar. If not, then that's about as far. It's up through, the US calls it calculus 2, so up through that. You would take linear algebra, matrix algebra. Those are usually the same course, but content, like understanding dimensional data that shows up that way. There's a course in the US called real analysis, which is usually thrown around for PhD program requirements. I think that I've never taken real analysis myself. My understanding of what it is the kind of work that you almost do, the kind of academic material you would do if you worked through relevant material in the other fields. But you can look it up. For statistics, probability, distribution theory, regression modeling, estimation versus inference, there's hypothesis testing, critical thinking. Some of that stuff, if you did a field that has statistical requirements, you probably have already done that in undergrad. If not, I have resources at the ends of this here to point you on how to pick all that stuff up. But again, statistics is incredibly important. Just a lot of the fundamental stuff is the most important.
Right. Cool. So now I think we come to the point where all those students might be waiting for this particular question. And this comes from Naman and Prakash. What are the top languages that one should learn for being a good data scientist?
The question from Prakash was top languages, and then Naman asked, what does it take to be an expert in the field? And so now we're moving a little bit out of the academic requirements and more towards like the actual, whether it's technological requirements or professional requirements, things like that. I love this question because I've dwelled on this for years as I've built up my skills to work with these things. And I think I have good answers for you, relevant answers for you. So let's talk about top languages when we say that here. And what does that mean? So some of you might have programming experience, some of you might not. This is a little more relevant. This will be easier to understand right now for those of you that do. So bear with me for a minute here. It's important to understand the distinction between a language, a programming language, and its implementation. So Python, for example, is a very popular general purpose programming language. It has like 6 implementations, which means that you can write the language on top of 6 different programs that interpret what you wrote to do things. So know that that's a big thing to consider when you're doing any software development work. It doesn't matter how it's working there. The best example I can think of that to make relevant to a lot of people is SQL, right? SQL is not a language, believe it or not. SQL is a language standard. And what that means is that any software can be built up and then use some flavor of SQL to understand what it is that you want. There's like 1,000 different query languages that are written using ANSI SQL. It's ridiculous. So an implementation would be Microsoft SQL Server or MySQL or PostgreSQL. All these things are systems that use something like SQL to talk to them. I only point that out because you'll run into a lot of frustration later if you don't know that now. So it's a language versus its implementation. So this is the question of like, what's a good language to learn for data work is one that comes up a lot on the internet at all when I help people that ask questions on forums and things. It's not enough that the answer to that is it's not enough just to be able to look up and say, okay, cool. I heard I should learn Python. I know how to write a for loop in Python and I can print my name and now I can go be a data scientist. Like we said several times up in the academic section, it's not about the tooling and it's not about the methodologies. It's about the subject matter expertise first and foremost. And then it's the fundamentals of how do you apply these tools to that subject matter expertise. So, you know, these different languages and software are not there to do your job for you. It's there to enable you to do your job better. Right. Software is only as smart as the person using it. So that's important.
So if I were to just inject right here, Brian, and I know you've got tons and tons of notes because this is pretty personal and close to you. But as a student, I'm a student in the in freshman first year, right? Sophomore, who's just learning how to code, right? What is the first language that I should pick up if I were to just start very fresh? What's going to be the first thing that I should
at school start? Or what should you pick up on your own?
At school or on your own.
At school, they won't probably, depending on your
they probably do C++.
They'll put you in C++.
Right.
For sure. Python is popular in the data space, but I'll be honest, I don't use Python for data science stuff. I use Python for everything else because it's lovely. there's a language called Python. It's very high level general purpose. If you think you want to do something with a computer, somebody has written a library in Python for you to do it. It's written in really, really easy English. It just is easy to write and read and use. I love it. I love it very much. So Python. It doesn't matter what your career choice is. Pick that up for something.
Right.
Whether it's data work or whether it's something else like web development or whether it's moving files around, whatever.
So will you say R? And I know you got tons of things, right? But we are 15 minutes in, right? So what about R, right? Between Python and R, where would you put those in terms of evolution in learning?
Everyone's going to disagree with me. R is the better language and software. There's a language called R, the letter R, that's better for tabular data, like rows and columns. It's just better, period. I could talk about this for weeks. I'll spare you the details. But out of the box, R works with tables. Python does not. SQL doesn't work the same way with tables. It's a mess. So those are the two competing languages you'll see for data work is Python and R. R is better for tables out of the box. Python is better for a lot of things. Really quick, I know we're pressed for time. I just want to go through here.
Yeah.
The four main languages that you should really understand are the SQL standard, which you can find anywhere on the internet. It's a few keywords. It's very easy to learn. Python and R, and then there's a language called Bash. It's a language in the sense that it's like when you open up the command line on your Mac or on your Linux machine, everyone ignores Bash. It's called Bash that when you open the terminal. It's important that if you don't understand it, you might not be able to use these other tools. So please use those. More rare stuff. I'm moving a little quickly because I want to make sure that we hit time here, but I want to make sure we get here. More rare, you might do a lot of work for data stuff in what's called PowerShell, Java, or another Java-like language, C or C++, Julia. Julia is a new language that I like a lot, but it's not very good. There's a lot of software and software platforms that help you be more successful. Understanding Linux-based operating systems like Ubuntu and Debian and things like that. Git is a version control system, which if you've done software development, you're familiar with. And then GitHub or Bitbucket or hosting platforms. Virtualization, like VirtualBox, virtual machines, things like that. Docker is a big technology that's popular these days. Docker itself is a containerization software. Containerization is an important thing to understand. And then cloud hosting stuff. I said this before. So Amazon, AWS, Google Cloud Platform, Microsoft Azure. These are all things that in the bigger ecosystem today, knowing these languages and software will help you be the most successful that you can be. But again, it's not enough just to know these things. You have to, these are things that help you do your job better. They don't do your job for you.
Right.
So understanding academic material and subject matter expertise is more important.
Right. So, and I want to point out, right, Ryan's probably given us like tons of information here. Yeah. He has tons of information written here.
This will all be written out.
Right. So we'll put this in the transcript and we will send this to you, right? So don't worry about taking notes or missing out a particular question. Yep. All right. I'm going to move on a little.
Skip that.
Right. And then go to, since the number of software engineers is growing exponentially, what can we do to stand out? And this question comes from Jatin.
So I thought about this question for a while. The one thing that I've decided on recommending for this is if you have access to GitHub or to Bitbucket, these are code hosting providers, right? Work on some projects and have them public on GitHub or on Bitbucket or something. So what I mean by that is that you can go to like an online tutorial and see how you do things like, oh, run this code and this thing and then it works. And now you have a web page. Congratulations. Not things like that. I'm not saying copy and paste tutorial code and stick it on your GitHub. Spend some time thinking about a problem you'd like to solve. It doesn't matter how stupid or small or insignificant it might be. What employers want to see this for standout applicants is for somebody to show the initiative and the independence to develop their own software. Again, it can be super small. It could be a command line program that just takes your name and figures out how much money you have in a fake bank account, right? Just something that shows that you had the willingness to go try something yourself that's software related and that you can provide value to that company, is what I would recommend. I have a ton of stuff on my GitHub. No one's ever looked at it. Most of my work speaks for itself, but if you're worried about it, make yourself public and do that. Right,
and that's the beauty about software, right? I mean, the way the world's changed. When I did my engineering, everything was just dependent on an industry provider for you to bring it, for them to bring you in and then provide you experience, right? With software, it's changed. you can actually just go back home after your college, just do your stuff, right? And just, as Ryan is saying, make it public.
This is stuff you can do at night while you're, in school.
Right.
Some of you might already have GitHub projects.
Right. So just make them public and make sure that, you keep on publishing stuff on there. Yep. It's important. Yep. In the same, same line of questions, this one comes from Tanmay, Akash, Rishabh, and Amarjeet. What they're trying to ask is, what should they do during their summer work, right? Summer 3 months down period that they have, and other, downtime that they might have, evenings, weekends. What should they be doing to actually get to a better footholding?
Yeah. And so again, all of this, we'll post this, we'll have links, so don't worry too much about it if I blast through this. But the bottom line is that I hope you like to read. I have a lot of, the question again is what can you do during your thing? But then what does somebody who doesn't have any prior experience in data science, where do they start? So I have a ton of resources. They're all books. So they're all really good books, and they're not as boring and dry as you might think. There's a couple videos for mathematical and statistics things. If you want to brush up on academic stuff like math, statistics, probability, whatever. If you've ever heard of Khan Academy, it's a video based learning platform. It's free. I taught myself calculus with Khan Academy. It's wonderful. Go check that out for sure. If you want to get deeper into stats, for example, there's a book called The Introduction to Statistical Learning by Rob Tibshirani and Trevor Hasty. That should be a free book. Again, we'll link this, don't worry. If you want to go even deeper than that, they have a harder version of that book that you can pick up. I haven't read it. It's too much, but it's there. To understanding what does data look like? Why would I ever want to work with data? And what is a database? Where does this stuff actually live? How do I work with it? There's a book called The Data Warehouse Toolkit by Ralph Kimball. It's like the industry standard for how a data warehouse is structured. It's a collection of read databases. For you to apply data science things, I'm moving because we have a little bit of a time crunch here, but also, again, we'll share these links, don't worry. There's a book called R for Data Science by Hadley Wickham and Garrett Rowland. It's focused on R. It's how do you use R for doing data transformation and analytical work. The knowledge applies to everything. It'll apply to, it doesn't matter if you're doing your work in SQL or Python or Julia or whatever. It just happens to be focused on R. It's a very good book. It's free. These are all free. More computer science stuff. There's a book called Data Structures and Algorithms. There's a ton of computer science resources. This one, though, I have linked specifically. There's one that I really like called Designing Data-Intensive Applications. And if you've used R before and you like R a lot, the same authors for the other R book wrote a book called Advanced R, which again focuses on R, but you get to see what a low-level implementation of a programming language looks like that you're familiar with, which is really cool. I really enjoyed that book a lot. I read it again all the time. So yeah, a lot of independent learning, I would say. And here's the resources for it. Again, we'll share these. But
right.
That's what I have. So.
Okay, cool. At this point, I wanted to address some of the questions around immigration and doing your master's in the U.S. or other countries internationally. But I'm going to skip those since this is we've got questions coming from the students through the chat.
We're going to post.
Yeah, and we're going to post all the answers. So I will make sure that your answers are answered, or your questions are answered, right? So please allow us a week or so to send you all those answers, right? But some of the questions I wanted to pick up from here. This is from Nikita, and she's saying, I'm an IT student with basic machine learning knowledge, right? How would my future be if I were to choose a career in data science? I think we've already answered that.
I think we have
that question.
The answer is you're on your way.
Right.
You're already, if you have basic machine learning knowledge, if you want to do more data science work, brush up, do more machine learning knowledge work, or do more machine learning work, excuse me.
Right.
And you can explore for yourself what that might look like. But it sounds like you've already got a good foundation. So.
Right. There was a question from Pramod. I think we've already answered that, which is, which programming language is better, R or Python, and why? I think we've already answered that.
They're better for different things. R is better for relational data, tabular data. Python is better for almost everything else.
Right. So pick Python before you pick R. Is that something you would suggest if they are still in college?
Yes. If you're still in college, pick Python first, but you need to learn both to be successful.
Right.
Yes.
This one's an interesting question from Rajneesh. I want to know how data science is helpful in ethical hacking. Is it related to ethical hacking?
It can be if you're like a white hat hacker who's trying to work on penetration testing. Maybe data science tools will facilitate you being able to, you know, implement better randomized algorithms to try to implement your crack solutions. I'm not too much of a security focused person, so I can't speak much to that. But I can imagine that if there's anything that requires statistical or randomization things when you're working on penetration testing, for example, data science tooling can probably help you do it faster or better. Not necessarily crack the system faster, but implement your testing faster, for sure. That's what I think off the top of my head.
Right. Then we have one question from Ayush, who's saying, I want to inquire if someone was looking into working in the data science sector, right? Would you advise to learn about generics of data science first, or to work towards learning a specific subset in data science like NLP? I don't know what that is.
Natural language processing.
Right. Weather model predictions, pattern recognition, etc.
Mm-hmm. So that's a really good question. Thank you for asking that. General knowledge. Focus on general stuff first. You know, you can like the first thing you'll stumble into might be a really specific subset like NLP. And natural language processing is such an incredibly recursive and nested statistical application that if you don't understand what it's doing, and people will crucify me for this on the internet, if you don't understand what your model is doing, don't use it. If you don't understand what the tool is doing, don't use it. Because if you can't explain it to your boss, why use it? That's my opinion. So starting with general knowledge about the higher level things of what is, it's still a lot of stuff we talked about today. What is the field? What are the problems that it solves? What are the different toolings? How do those lower level toolings work? Because once you start to look and you get to something like NLP, what you realize is that if you'd started with probability, distribution theory, regression modeling, logistic regression, and then suddenly you realize that NLP is just an applied use case of a regression model, just like most higher level models are. But you need, my opinion, a strong opinion, you just need to understand the earlier fundamental stuff first. So start broad, figure out what interests you the most, and then once you have the broad knowledge, then you can start to go deeper and specialize into something. It's a really good question. Thank you.
This question, the next one is from Ayush again. And I don't know if you would have the answer to that right now, but we can post this later on. Mm-hmm. Could you recommend some resources that you think hold good knowledge about machine learning?
An Introduction to Statistical Learning by Rob, Tim Sharoni, and Trevor Hasty. It's a book that I'll share a link to when we're done here.
Right, so you already answered that one in the other question. Right?
Yeah, I've heard nothing but good things. They even have a YouTube series. They're kind of weird old dudes, so it's kind of weird to watch them, but they do have a YouTube series that follows the book. And I'll share all of that when I can. So
right, okay, cool. I think we've got a couple of more minutes left, so I'm gonna go into this. Right, this is a very popular question. Should I do a master's in tech or should I do an MBA? It totally depends on you guys. A master's degree would actually make, you could pick up a master's degree in technology if you want to move into the technology field, right? If that is something that you're passionate about. If I'm a mechanical engineer and I want to, dwell a little deeper into fluid mechanics, for example, right? I'm going to go into a master's degree. Once I'm in the industry though, right? Then I will realize if my passion really is fluid mechanics or not, right? As Ryan was pointing out before, that once you're in the industry, that is when your evolution actually starts. The industry starts to push you in a certain direction, and then you realize if what you're trying to do is that something that you're passionate about or not. And that is when usually people pick up an MBA, right? I know that there's this culture now that, you have to do a bachelor's and then you have to go work for a few years and then do a master's or an MBA. It's not necessary.
You know how much time I had off between my bachelor's and my master's degree?
How much?
3 days.
Right. Right.
I literally had a weekend off.
Right. And that's how usually it is. With the cool thing about a master's degree is, you could pivot your area, right? If you're an electrical engineer, you can go into computer science, or if you're a computer science person, you can actually pick up biochemical engineering or business, right? So you can go into engineering management for that example, right? With a master's, you need to have some experience. Or with an MBA, don't jump into an MBA, right? just because you think that everybody's actually going that way, right? That's not cool. Don't do that. There's a reason why good universities require you to have work experience for an MBA, and that reason is that you would, in those 3 or 4 years that you worked in the industry, you would have understood what your calling is, right? And that is when you make that switch. So I've seen chemical engineers going into finance for their MBA, or somebody who was in finance going into marketing, and that is where you definitely pivot, right? But you have to make up your mind, and don't just think about master's versus MBA. A lot of people would do a master's degree, then go work in the industry in that area that they've done their master's degree in, and then probably 3 or 4 years down, they would do an MBA, right? That doesn't hurt. So it's definitely your choice. I see one more question that's come in, and I'm going to give those presidents over others.
I think you actually answered most of what they had written down in breath. So.
Right. Okay. This is from Vivek Dixit. He's saying, is it important to know C language before learning Python, or can we learn Python first?
No. Learn Python first for sure. You might never touch C again if you learn Python. it's that good. It won't be as fast, but you don't need to know C.
Right. And it's sort of, I think and I'm going to take this 1 minute and just rave about this, that I see a lot of colleges, right, still teaching C, C++. And the industry does not necessarily use that all the time.
Well, nah, not 100% true. But starting with them is weird. I agree. Starting with C or C++ for a computer science student. Well, no, that's not true. There's a lot of fields that shouldn't teach the software languages they do. In the university I went to, they taught us a language called SAS, which is a high-level statistical framework language, and it's garbage, and it's not free, it's expensive. But that's what the industry uses. And so computer science students it's helpful to know C and C++ and Java. Engineering students, C++ for machine programming, like things like that. But Python can do a lot of that, especially engineering. I've made Internet of Things like IoT objects with Python code.
Yeah.
It's the hesitation of universities to teach higher level language like Python friends is really weird to me. That's a good observation, though.
Right. Yeah. So yeah, guys, if you don't necessarily have to just restrain yourself to whatever the college is teaching you. Python's a good language, and Brian's right. Go pick that up. Finally, I want to say there were questions about how to go figure out what to do for masters and all those things. That's why we are here. You can download our app, right? Go create your profile, and somebody from our team is going to start helping you out for free. We don't charge students because we were international students ourselves at a point. I mean, he wasn't, I was. So we understand what the pain points are, right? If you go download our app, put your profile in, the app actually walks you from step 1, which is how to get even a passport made, to step Z, which is, now I'm on campus, what to do to be successful. So you want to make sure that, you download our app and then create your profile there so that our team can reach out to you and chalk out a plan for you. So we're helping a lot of students now, and we would love to help you as well. With that, I want to close. I think Ryan's got something.
I was just saying, one of the things I was going to say, if there's anything I can ever help with, or you want more resources, and we'll share all this. My handle on everything is...
this one's upside. I think it's...
Is it backwards?
Yeah, it is backwards.
Oh, no.
So you won't be able to do that.
My handle everywhere is RYAPRIC.
We'll put that in.
GitHub, LinkedIn. Yeah, if they're up right now, I'm going to look and know.
Right.
So always feel free to reach out if you have any pressing questions I can help with. I'm always happy to help students with what they're trying to plan for their future. So.
All right, cool. Guys, thank you so much for your time. Enjoy your weekend, and we'll see you soon with the next session. Thank you so much. Bye-bye.